Step 1, the server starts off with a minuscule 0.2% CPU usage. Step 2, I create a CPU intensive infinite loop. Step 3, the CPU usage rises to 5.7% and then 100%. Are you going to know about that?
Your software system's health is not binary. It's not quite as simple as broken versus working. It might be slow, it might need constant restarting, it might be under attack by hackers, it might be running perfectly fine right now, but teetering on the edge of disaster. That's where system monitoring comes in. The topic is huge, so I'm just going to focus on a small subset of what I found helpful. So I've opened up my logs here again, and I'm going to search for fatal database errors using this regex I prepared earlier. Now, let's look at what turns up. So the first few entries are sort of weird. I'm just going to skip them for now. They're not terribly interesting. Here's an interesting one. Fatal. Password authentication failed for user Postgres. Fatal. No pghba.conf entry for host 148.153.65.30. So this is basically a hacking attempt into my Postgres, but the host-based authentication HBA file is preventing this foreign host from entering, as it should. I use a hosted Postgres service, and I trust them. Therefore, I do not get email notifications about this particular error. But if I was running a piece of software that had higher security needs than Oxbridge Notes, then I might want to get emails for every single such attempt. Each of these errors had the SQL error code 28,000. So what I'm going to do is copy that and then paste it over here to ensure that I can do a regex filter just for that. It takes a second, and sure enough, it's just those particular entries. The reason I might want to do this is because if I'm more security conscious, I'll want to get an email, some sort of alert every time this thing happens. So I'm testing my filter here. Then I'm going to create a tag and alert. And I'm going to add a new one here. And I can say DB hack attempt or whatever. I put the pattern in here. And then I say it's fatal or whatever, or it doesn't matter. And then I can set an alert that I get an email or whatever. I can save changes. I'm not actually going to save changes because I don't need this one, but that's how you do something like that. That's how you scan your logs in order to detect issues with your system. I do, however, have tags and alerts for other kind of things that are more important to me. You can see them all here. And the most important one by far for me is when my memory quota is exceeded, when I'm out of RAM. This is a very common issue whenever you're running a web server. This brings me on to my next point. You need to be able to check in with your server's stats, i.e. RAM, CPU at any instance. Depending on the platform you deployed to, like raw Ubuntu, AWS, platforms as a service like Heroku, there will be all sorts of tools that are more or less helpful in order to monitor your system resources and so on. One of the most popular DIY approaches is Monit, which you're looking at right now. This can be deployed for free on any server and then is available as a sort of web app on a certain port. We're looking at my Monit instance for a microserver. I have a microservice that just does some sort of document conversion for me. The main thing you'll notice is the overall system stats. It's okay. There's pretty much zero load on it right now. The CPU is at 0.2%. Memory usage is 10%. Basically, this server is not being used. There's no workload being given to it. It's a very bursty sort of workload that it receives. So as an experiment, I'm going to create an artificial load on this server. So first I'm going to SSH in. I have this little handy alias here, root at oxnotes doc services, or rather the oxnote doc services is the alias. I don't have to type in the IP address. Now you can see I'm inside the server. I'm just going to clear it. Next, I'm going to create an infinite loop, one for every single CPU on the system in order to use up all the resources, to waste the resources. So let's see how many processors I have with nproc. Only one, okay. So that'll make the script a lot easier. So I'm just going to do a while script and make it do nothing. And let's see what happens. So I'm running that there, and I'm going to skip back over to Monit and see if I notice anything. Already the CPU usage is starting to climb upwards. It's at 5.7%. By the way, this US means user space stuff, and this is system stuff. Oh, it jumped to 100%. The load is based on an average over a certain time span.
If this were to continue for much longer,
Monit would send me an email. I've given it some sort of email config to SendGrid or something, and it would tell me that there's a problem with my server, its resources are too heavily used, and I need to scale up. Anyway, I don't want that to happen, so I'm going to cancel this fake workload. Next, I'm going to show you another perspective on system monitoring. This one a little more long-term. These techniques are not so much about getting alerted when your system is burning up in flames, but rather about getting a general indication of its health. Think of this as akin to taking your blood pressure or weighing yourself regularly. You're looking here at the stats over the last 1 week of my primary Oxbridge Notes server. For most web developers, I believe memory usage is the biggest issue they'll face. The reason why RAM is an issue is because if you run out, then you have to swap to disk, which is orders of magnitude slower and also really CPU intensive. This means that your app is going to drop requests, lose information, bug out during payments, and generally become a heaping pile of useless crap until it's rebooted and the whole process begins again. So this is my memory graph over the last week. You can see it has a certain pattern that it increases slightly, then levels, and then it goes down again. And that happens again and it goes down. The reason for this is because there's a daily restart. Unfortunately, the CSS is a bit weird here because I've zoomed in so much, but this daily restart should actually correspond to the peak here. Now, the reason why memory increases over time is because more parts of my code get loaded and so on, but it doesn't increase to infinity. That's a good thing. That means I don't have a memory leak. In the past, I did have a memory leak, and the graph would look more like increase, 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 increase. I also had much more RAM then, something like 2 gigabytes assigned. Increase, 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 then restart, and very frequent restarts because it kept maxing out. That's a really bad situation to be in. Scrolling down further, we have response time. How long does it take my server to give a response to the browser? This is a much higher level, more customer-centric metric than RAM. While RAM issues can cause a slow response time, a lot of other things can too, like crappy network interfaces, slow SQL queries, poor caching, etc., etc. So my median is 39 milliseconds, which I find pretty reasonable, and 95% of requests are completed in under 150 milliseconds. This isn't amazing, but it's good enough for my purposes. See you next week.